Hi, I'm Ann Stinnett. I'm the math specialist for the Knox County Schools. I have the privilege of working in classrooms across the district with all of our wonderful teachers and students. And hopefully I've come to teach your math class before. And today I'm going to bring you week 3 of 8th grade math, and it's going to be a little bit different from the first 2 weeks. We've spent the first 2 weeks reviewing proportional and non-proportional relationships, looking at slope-intercept form and calculating slope of a line using tables and graphs and ordered pairs. These are really critical skills for your future math courses. So today we're going to do a review of another really important skill that involves working with equations. So it's going to look a little bit different. It's a little bit more practice with paper, pencil, and I'm going to walk you through it. I'm going to start with going over the challenge I posed at the end of week 1, and I'm going to give you a solution to that. We're going to move into something called a splat. If I've ever taught your class, I've probably done one of these because they are my favorite. They are something that involves the whole family. So if you have anyone sitting around you, feel free to let them join in your splat. And they come from a famous math guy, Steve Wyborn. He has a website that I'll share with you at the end, and another puzzle that you might want to use to engage your brain in some math throughout the week. So we're going to get started here with the solution to week 1's challenge problem, which was from a website called Open Middle. And your directions were to use the digits 1 through 9 at most one time each to fill in the boxes to find the greatest and least possible slopes. So an answer would be either the ordered pairs 2, 1, and 3, 9 for the greatest slope, where if you take the difference in the y values over the difference in the x values, you end up with 9 minus 1 over 3 minus 2, which gives us a slope of 8. Or I could reverse the y values and do 1 minus 9 to give me negative 8 over 1, and so the least possible slope would be negative 8. So if there are others you could come up with, feel free to check out the other problems they have on Open Middle. Again, it's a resource that the whole family could do if you're interested in doing some more math puzzles. So now we're going to jump into our splat. We're going to start with some dot patterns, and I want you just to take a minute to count them. How many dots do you see, and how do you see them? When you have an answer, feel free to share it if you have someone sitting with you. But when I counted 14, and there's a bunch of different ways to count. Sometimes, especially if you have a younger brother or sister at home, they might count one at a time and count each dot individually. You may have chosen to count in groups of 2 all the way to 14 in any different way. You might have seen larger groups of maybe 3, or a group of 4, a group of 4, a group of 4, and a group of 2. You may have seen groups of 5, 2 groups of 5 to make 10, and 4 more to make 14. Be as creative as you want. But the next thing I want to do is I'm going to put some splats over the dots. And one thing you can assume is that each splat has the same number of dots underneath it. So all 3 splats are equal. So think about for a second how many dots are under each splat. And if you do have somebody with you, how do you know? You might want to pause the video at this point and take a little more time if you need it. But here is the answer. There are 4 splats, or 4 dots under each splat. And there's a couple ways that you might want to solve these. One, you might just use thinking, arithmetic, basic problem solving, and you knew if you started with 14 and there were 2 dots showing that there had to have been 12 dots underneath the splats, and if you divide that into 3 equal groups, that means there are 4 dots under each splat. You could get a little bit more sophisticated and show this algebraically, and this is going to help with what we're doing today. Is if I see the 3 splats, those are my unknowns or my variables. So I modeled that here with x. So 3 groups of an unknown, or 3x, plus the 2 dots that I could see equals 14, because I knew that was the total. And then to solve this, I subtracted 2, and that gave me 3x equals 12. and then I divided by 3 to isolate the variable to see that x equals 4. So pause for just a minute and think about how these two solutions are alike and how they're different. You might notice that in both of them, we subtract 2 first. And if you remember the rules for two-step equations, when you have equations like this, your teacher probably always said to take care of the addition and subtraction first, and then do the inverse of multiplication and division, which is exactly what we did with the arithmetic way of solving your splat. So there's a very quick review of what we're going to do today, which involves solving equations. So your standard for the day is under expressions and equations. We're going to solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. That statement is a lot, there's a mouthful, so let's review, like we did before, a couple of the words that might be helpful. First of all, linear equations are equations whose solutions form a straight line on a coordinate plane. So in other words, none of the variables have an exponent greater than 1, or none of the variables are used in a denominator. So here's an example of just a basic two-step equation. We might have a y value, or you more commonly in 8th grade know y equals mx plus b. And so here's another example of a linear equation. Notice I don't have any x squareds, I don't have any x's or y's in my denominators. This second example will give you both the x and the y value. And also, you'll notice the word equation has the word equal almost in it. So an equation has to have an equal sign. And just to review the difference between an expression and an equation is that an expression doesn't have to have that equal sign. So we could say 7 plus 4y is an expression equal to 19, another expression. But what makes this an equation is the equal sign. The second thing we want to review is a rational number. A rational number is any number that can be expressed as a ratio of two integers. So some examples are 1 75/100, or 7/4, or they include the integers. So I could have a negative 1/3, or a negative that says 33/100, or 1/3 is that 3 repeating, which makes that a rational number. Our most famous irrational number, of course, is pi, because the decimal values don't repeat, and they do not, it's an irrational number. So for today, really the rational numbers mean we're going to be solving equations with positive and negative fractions and decimals. The next word is coefficient, and that is the number that is multiplied by the variable in an algebraic expression. So it's, in other words, the number in front of the variable. So in 5 times b, 5 is the coefficient, and in negative 1/2 of x, negative 1/2 is the coefficient. And the next word is the distributive property. You've probably been using this since you were in 3rd grade, learning your multiplication facts and how to break numbers apart. But that's just when we multiply a number by a group of numbers that are added together. That's the distributive property here in this example. And it's the same as doing each product separately. So if you have 5 times the quantity 20 plus 1, I could think of that as 5 times 21, or 5 times 20, where I'm distributing that 5 to each term, and 5 times 1, and then adding those two products together, which will be 100 plus 5. The second example is more algebraic, so I have that variable, and I will need to distribute this negative 2 to the variable x and to the constant 4. So when I distribute that negative 2 to that positive 4, I get a negative 8. The trick in using the distributive property with integers is making sure that you keep up with your positives and negatives, and knowing that that operator there in front of the 4 will always go with that constant. And the final term is like terms. Those are terms that have the same variable raised to the same exponents. So in the first example, 7x plus 3x, those are like terms because they both have x to the first power. So 7x and 3x are like because they can be combined to make 10x. In the second expression, 3y and negative 2y are like terms, so we can put 3 and negative 2 together to make 1y, or just y. And then the second one is 4 and -7. Those are just your basic numbers. We call those constants because they do not change. And 4 and -7 combined make -3. So we're going to use all of these terms in your packet this week. So I would suggest at this point stopping the video and trying to work through the problems this week and see how you do. The answers are at the bottom, and that's okay. You can always try to match up your work with the answer and try to make sense of it. But in the second part of this video, I'm going to show you how to get the answers. Here is your first problem, and I would suggest writing it out on some notebook paper if you have it. And the first thing we're going to do is distribute. So looking at the first expression in the parentheses, there's nothing to distribute. But the second, there's like an imaginary 1 there, or a -1, and we're going to end up distributing that to both terms in the parentheses. So the first thing I'm going to do is just copy down the first expression without parentheses. And then I'm going to think -1 times 1.5 is -1.5m. -1 times 1.2, or 1 2/10, is -1 2/10. And then I'm going to copy the rest of the equation. Now I have to think about my like terms. I have -2500 and -1.5. When I put those together, I get -1 7500 m. My constants are -2 and -1 2/10. When I put those together, I get -3 2/10. So now my terms are combined and I can solve the equation. I need to isolate the variable m and thinking about doing the same thing to both sides of the equal sign. So to eliminate 3 2/10, I'm going to do the opposite of subtract, which is add, and I'm going to add that to both sides of the equal sign. So I'm going to bring down my variable. 3 2/10 negative plus 3 2/10 makes 0, and then I add -11 6/10 plus 3 2/10 to get -8 4/10. Now the opposite of multiply, or the inverse, is divide. So to isolate the variable, I'm dividing here, and I end up with 1m, and -8 4/10 divided by -1 7500. In case you forgot how to divide by decimals and your calculator is not handy, I'm going to set up my division problem, multiply both terms by 100 to kind of move that decimal out of the way. And I have to think how many groups of 175 will go into 840, and that's 4. So 4 times 175 is 700. I subtract, add a 0, and end up with 1400. Well, I can just double the last one, and 8 groups of 175 make 1400. So the solution is 4.8. So there's your answer to number 1. You can go back and check by substituting 4.8 or 4 8/10 into the original equation and making sure that it's true. Your second one is about Marcia and her phone service. So there's 2 data packages. One charges an initial fee of $50 and $13.25 per month. The other has no initial fee but charges $25.75 per month for the same data package. So the question, after how many months would Marcia have paid the same amount for either data package? So I set mine up with package 1 and package 2, thinking about the initial fee and the cost per month, and then the cost per month. So my expressions are 50 plus $13.25 per month. I don't know the months, so that's my variable m. And for package 2, I have $25.75 times the number of months. Now, if I'm trying to figure out when these are going to be the same, I simply make the 2 expressions equal to each other, and now all I have to do is solve for m. And I have variables on both sides, so just like with constant numbers, I can manipulate these by moving them around using inverse operations. So I'm going to start by subtracting $13.25 times m from both sides of the equation. And that'll give me the number 50 by itself on one side, and then the coefficient and the variable on the other side. There's a couple different ways you could start this, but this would be the most efficient. And I end up, after subtracting from both sides, I end up with 50 equals $12.50 per month. I still don't have m by itself, so I'm not finished. I need to do the opposite or the inverse of multiplication here, so I'm going to divide both sides by 1250. And I can just think about how many groups of 1250 are in 50. Well, I know 2 groups of 1250 make 25, so I can double that and know that 4 groups make 50. So if m equals 4, that means that after 4 months, Marcia would have paid the same amount for either data package. The next problem is Jamal states that a times x plus b is equal to a times the quantity x plus c. Given that a, b, and c are not equal to 0, so none of my variables can be 0, what must be the value of c for Jamal's statement to be true? So this one looks a little bit trickier, but we're going to use the same exact procedure that we've used for the other ones and the same terminology. It's just now we've replaced the numbers with variables, but all the properties will still work the same. So I'm going to begin by starting with the distributive property and distributing that a to both x and positive c. So when I rewrite the equation, I end up with a times x plus b, nothing changed there. And now a times x is ax plus a times c, which is ac. Now I just need to solve this equation by isolating c to figure out c. I notice I have 2 like terms, a times x, on both sides. So if I put those together, I can subtract it from one side, do the same thing to the other side to keep my equation balanced. And in both cases, you might notice they're going to cancel out. So a times x minus a times x is nothing. I'm left with b equals, here again, a times x minus a times x is nothing, and I bring down the a times c. I still don't have c by itself, so to do that, the inverse of multiplication is division. So to get c by itself, I need to divide by a. So if I divide both sides of the equation by a, I end up now, c is isolated, it's by itself, and I now have c equals b divided by a. And using the commutative property, I could write that one of 2 ways, the way you see here, or c equals b divided by a. And that's all you need to do. You don't have a numerical answer for this one because it is going to remain algebraic. For your 4th problem, we have a statement that we need to interpret in order to write the equation. So twice the difference of a number, which we're going to call n, and 7, is equal to 4 less than the product of 5 and the number n. Then we have to solve for n to figure out the value of n. So I'm going to start with twice, which is 2 times. And I know that times something, that difference of a number and 7 is going to be a quantity, and I'm going to group that with parentheses. And that's going to be equal to 4 less than, so that's minus 4, and then 5 and the number n. So here's the equation that I'm going to be working with. And again, like all the others, start by distributing your 2 to each term in parentheses. So we have 2 times n. 2 times negative 7 is negative 14. And then the rest of the equation remains unchanged. So I can think about combining like terms. For this one, just the way my brain works, and you don't have to start the same way I do, and that's okay. But I'm going to add 4 to both sides, and I end up with 2n, that did not change. Negative 14 plus 4 is negative 10. And I had to think about that one for a second, obviously. And 5n, negative 4 plus 4 is 0, so I can cross those out. Now I need to put my variables together. So in this case, I'm going to subtract 2 times n from both sides of the equal sign. And once I do that, the 2 n's cancel out, and I have negative 10 equals 3n. So next, to isolate the variable or get n by itself, I need to divide both sides by 3. And I can leave it just like that. 3 over 3 is 1n, and I can leave it as n equals negative 10 thirds. or I could convert that improper fraction to a mixed number. It depends on what I'm going to do with my solution, but that's equivalent to negative 3 1/3. And the final problem is what value of the coefficient b, which is right here, makes the equation true for any real number. So I've got to figure out how to make this expression on this side of the equal sign equal to this expression, bx plus 9. So I'm going to start, you guessed it, just like all the others, by using the distributive property. And when I distribute that negative 3 to both terms in parentheses, I end up with negative 6x. Negative 3 times negative 3 is positive 9. And then the rest of the equation gets copied down just like it is. I'm not ready to do anything with that part yet. And now I can combine like terms. So I'm going to put negative 6x together with positive 5x, and negative 6 plus positive 5 is negative 1x. And I didn't write the 1. You can. And then I'm going to bring down the plus 9. And then I'm going to write the other expression in my equation, which is bx plus 9. Now pause here for a minute and you might notice something. That they're almost exactly the same. They both have a plus 9 and they both have the variable x. The difference is in the first expression, negative x plus 9, I have that negative 1x. So I'm going to write it out. So in order for that to be true, the second expression also has to be negative 1x plus 9. So you might notice that if I put in that negative 1 where b is, for this to be true and both expressions to be equal, b has to equal negative 1. There's nothing else that it can equal. So b equals negative 1. Again, all of those are using the same ideas, the same terms that we talked about in the beginning of this video, just different ways of practicing it. So if you're wanting to challenge your brain just a little bit more, and you really like the splats, they're one of my favorite things, you can check out stevewyborny.com, and you can see right here he has a lot of popular downloads. You have to have PowerPoint for a lot of these, the cube conversations, the hundreds chart puzzles, and there's even fraction splats. These are a lot of fun. If you have younger kids at home, the ESTA mysteries are great. Our family loves to do these together. And one more thing I wanted to show you is the Solve Me mobiles. This works only on iPad or on the computer, so hopefully you have access. But this is a neat little game that you can play that kind of reinforces what we just did. There's different levels. I like to go to Puzzler because I've played these a little bit. But what you end up with is a puzzle like this. I'll tell you what this tutorial says here in a second, is I have to figure out if these teardrops equal 6, how do I balance that with 1 teardrop and 4 trapezoids so that I can figure out what the trapezoids mean. You can figure these out just using problem solving and guessing and checking, but you can also pull down the little bars at the top, and it sets up a lovely equation where you can see the like terms and the variable, and you can solve them algebraically if you want to. So I hope you have some fun doing some puzzles, doing some math. I hope you're taking care of yourself, and I look forward to either seeing you back in school or doing a couple of videos in the future. Take good care, and we'll see you soon. Bye-bye.